Good evening, students. The circuit which we are going to discuss now is sample and hold circuit in your module 3 of our course 17 LD01 analog ICs and applications. Hope you all remember the name of the course because of being more trauma going in our country and all over the world. So we can straight away going into the topic sample and hold circuit. So from the name itself, the circuit can be categorized into two. One is sampling of the signal. It is preferably the analog signal, and the second I'll state this is term 1 and this is term 2, and the term 2 is holding the signal for a small interval holding the signal for a very small interval. Okay, this can be done by two components, maybe in sampling and hold may be done by the sampling operation, and hold operation can be done by two components, that is your electronic switch and capacitor. So before going deeply into the topic, that is sample and hold circuit, so let we have a discussion about the purpose of the circuit. What is the reason for studying the circuit? The purpose mainly relies on the typical, when we consider a typical analog to digital converter or a signal processing plant, is, let me say, there is an analog signal coming inside like this. There is an analog, this is a typical analog signal, maybe an electrical or any non-electrical signal. If it is a non-electrical, it will definitely fit to a component called as a transducer, which converts any form of a signal into an electrical signal, which will be given to a filter. In order to smoothen this signal, the processed signal, it is given to a circuit called as, what we got to study is called as your sample and hold circuit. It is called as your sample and hold circuit. Then the signal is converted into its digital form by a circuit called as analog to digital converter. Then it is processed by a signal processing unit, say maybe a digital maybe a digital signal processing unit, and then once again if this contains more and more errors, and this will be converted into digital form, and then it is processed perfectly, and then once again this digital data is converted into what? Analog converter. So all these topics about analog to digital converter and digital to analog converter we have studied in our classes in a deeper manner itself. So if you want to have a better clarification about these topics, you can refer our class note material de-Barre converter. So then that de-Barre converter will give the same analog input in a better processed manner, or a better purified manner, which is what more of the applications are concerned about. So throughout the circuit we know how an analog to digital converter works, how a digital to analog converter works, how the signal is processed. You should have been studied in a course called as signal processing, digital signal processing. So we also studied about the digital to analog converter. So we were to discuss about the topic sample and hold circuit. So that is what we are going to discuss about it. Okay, so the main purpose is, when I supposed to process a signal, an analog signal, in order to rectify the noises in that signal, we need to have a process through that is called as the analog signal, that is which is a non-electrical or electrical signal, which is converted into a digital form. Before converting into its digital form, it will be sampled, and that signal is called as sample and hold signal, and that unit is called as sample and hold unit or sample and hold circuit. Sample and hold circuit called as sample and hold circuit. So then it is, as usual I said, it is processed and it is converted into, and all those things will happen which you should have been known about it. So going into deeply about this sample and hold circuit, I already said, let me go more deeper into that sample and hold circuit. So I already said it is a sample and hold circuit is a part of two circuit. A sample and hold circuit is a part of two circuit, namely the sampling circuit and the hold circuit. Sampling circuit and the hold circuit, so combinedly called as sample and hold circuit. So in order to accomplish this operation, so two components plays a vital role, as I said already, as a basic issue, that is a basic concept, that is an electronic switch. And for the purpose of sampling, that is an electronic switch. As we know that a switch generally performs a function called as transient function, that is on and off. And the capacitor, a hold, is accomplished by, already said that, placed by a simple capacitor. Do you know that a capacitor is a static charge storing device? So let me proceed further. So as I said, that is an electronic switch. It is a composition of an electronic switch and a capacitor. So coming to the electronic switch, you preferably please choose for a better sample and hold circuit, preferably use an electronic switch which have a high switching speed. High switching speed, that is the on and off time should be very low. The on and off time should be very low, and hence the switching frequency, and hence the switching frequency is very high. I got to say, choose an electronic switch that is whose switching speed is much high, that is the on and off time should be low, so that as the frequency and time period are of inverse nature, so I got to say the switching frequency would be very high. So you know that the basic electronic switches, you can use a diode, you can use a transistor, that is a BJT, and even you are using MOS switches. As we already know as a basic, MOS switches or that is FET switch, FET MOS or FET switches, that is FET switches will have a very high switching speed, so preferably you can go for a FET switch to accomplish the sampling operation, as the FET switch will have a very low on off time. So the switching so choosing a high switching speed switch, that is it is preferably to use a FET switch to accomplish the sampling operation. So, and you can use a capacitor for charging and discharging the analog value or the analog signal. So let me see how it works. So first we will discuss about the sampling circuit, which is which is accomplished by a component called as an electronic switch. As I already said, it is an electronic switch. It is an electronic switch. So I already said that choosing as FET kind of a switch will provide a very high switching frequency, will provide a very high switching frequency. Even the switching time will be in the ranges of nanoseconds and even picoseconds. Very low switching time in the ranges of 10 power minus 9 and 10 power minus 12 seconds. Okay, so just listen. So if I have a FET switch like this, just listen. A simple FET switch which I am going to draw like this, maybe a very simple FET switch. It's maybe a PMOS type of a switch. So that is our gate terminal, and it's a drain and a source, regardless of it may be a MOSFET or a JFET. So it is a simple switch. So one more thing I need to say is, for us, moreover for a FET kind of a switches, the impedance, the on-time impedance or the input impedance will be in the ranges of infinitive during the off state. It is very important. During the off state, the impedance offered by the switch will be infinitive. So it is also a very advantageous aspect. Okay, So I can give, so I can use another kind of a signal here in order to turn this on and off. Suppose if I use a square pulse like this, so when I give, possibly this is a p type, so this is my positive signal, so which makes this gate to on state, this switch to on, and this negative will automatically turns this what switch to off. So when I give input over here V in, and let me take a output over there V out, so a load resistance, it is RL. So we can say V in, the incoming input signal. So when I say this square pulse goes, so let me have the square pulse like this, that is, let me have, this is V gate, VG. So this is my VG gate signal when the gate signal is high, that is 1. So let me say the gate is on, that is your switch is on. So let me say this is the transistor is considered as the FET is considered as Q. When Vg goes 1, the square pulse is high, then the transistor Q is in on state. Okay, as I said, during the off state of the switch or the FET, it offers infinite resistance, and during the on state it will offer what? It is a short circuit, so it will offer zero resistance. So no signal will be stored across this zero resistance transistor, and either of the input will be present across the load. So the output V out will be ultimately what? V in. So let me explain it as a truth table for you. So equivalently, let me draw this as a switch. So let me draw like this. So this is my gate, this is my transistor, so I'll equivalently draw it as a switch like this. That's my switch. Yes, when I give the command over here, this is on and off. Okay, this is on and off. So equivalently, let me draw the switch like that. So the input is V in, V in. So given to the, let me draw the switch equivalently. This is my switch, that is the equivalent circuit of the FET, and the resistances like this, RL. So when I give 1 to this control, the switch will be on. So V in will be V out. V out will be equal to V in. So if I put it as a, draw it as a truth table, so V in, so the, let me put it as the what that I said, the input given to the given to turn on and off the switch is control voltage. Let me put it as VC. And what about your V out? Okay, so V in, I am giving it as V in. So if V control voltage is high, that is 1, so V out automatically what? V in. And same input V in is going, that is an analog signal. If control voltage is 0, all the signal is stored across this switch and no output will be provided, so V out will be automatically 0. So the signal, so if suppose if the signal is like this, if I send a signal like this, so as far as it is 1, all the signal will be inside like this, the sine wave will be available for that. When the switching goes to 0, no signal will be present. So what that means, the input will be allowed at 1 logics of the switch. The input will not be allowed at 0 logics of the switch. So I can say when my switch is on, so I can get the maximum or the entire input. The switch is off, the Vout is 0, provided for an ideal case there is no on state drop across the switch. So this is the equivalent. So look here, the V input voltage was in series with the arrangement of the switch, or else in simple words I can say the switch and the input voltage are in series to each other. So such a kind of switches can be called as series switch. See that Vin is directly connected in series fashion to the switch. That is Vin. That is your RL. That is your V0. Suppose if I make the switch that is shunt to the input voltage, that is shunt to the input voltage, then such a kind of a switch is called as shunt switch. So let me draw it now as shunt switch. It is a typical shunt switch. So I said the switch connection is in shunt with, it is parallel to the input voltage. So let me draw that, listen carefully. So this is my input voltage and this is my resistance. In order to safeguard the switch, in order to have a protection to the switch, so let me see this RD. So it is connected to the drain of the MOSFET or that FET switch. So here I'll give the gate voltage or the control voltage VC. I'll simply ground the source terminal. Yes, G. So here look that the Vn is in shunt connection with what? So you can understand in other manner that this is my Vn. So it is in shunt to the input voltage. And simply it is also you can say V0 is also in what? Shunt to the switch. So now listen carefully. The switch will offer when VC is high, that is positive pulse, this one, what happens? That is your Q. This is my Q. Q will be on, which offers what? Zero resistance. The resistance would be zero, so no voltage will be present across here. As from the basic concept, the short circuit will provide zero voltage. All the voltage will be stored across this RD. So when VC is high and V0 is equal to what? Simply 0. I'll put it in a table, don't worry. So coming to this fellow, so when VC is low, so coming here, what happens? Q is off. So off transistor will provide infinite resistance, so Vout will have the entire V in here. This will provide you the difference between a shunt switch and a series switch. Let me construct it as a truth table for you. So this is your V in as it is. That is your V control voltage and your V out. So V in as usual, it is given V in constant voltage. V in is applied and as a constant input voltage. It is analog voltage. So whenever when V in VC is high, that is 1, V out is 0, then V in as it is, VC is 0, V out will be V in. Provided that the switch is having 0 on state voltage. So we can able to categorize the switch which we are going to use for sampling and hold. Okay, so when we supposed to use a MOSFET or a FET switch, I got to say the switching speed is very high. So this kind of a switches are called as high speed switches. High speed switches. So this kind of operation can be even accomplished in your laboratories using a basic BC107 transistor. But when you go for application, kindly choose a high frequency MOSFET or a JFET. So preferably, even when you're supposed to try in laboratory to visualize a better output, you can use a JFET called as BFW10. It is a high frequency junction field effect transistor, which you can use it for your while testing the circuit in your laboratory. So I already said the sample and hold circuit or the categories are categorized into two. One is my sample circuit, which is accomplished by a switch, sampling switch, preferably a FET switch. So like this, I got to give V in. So and suppose I'm using a series switch, so my connection would be like this. So I have a protection resistor RD. So listen carefully, this is my control voltage. Let me put a capacitor over here at the load. So see, so V naught or V out. What about the effect of capacitance in the circuit? Capacitor in the circuit. So Vn is an analog voltage. Say for my comfortability, it is a sinusoidal signal. What happens? So when the control voltage Vc goes high, that is control voltage is a square pulse. During the high, what you can have, the switch is on, that is your Q is on, and which charges the capacitor, this will charges the capacitor depending upon the time constant Rd times C. And once when the go for Vc is low, what happens? So the Q goes off. So when Q is off, what has to be done? When Q is off, the switch will offer infinite resistance. So this is off. So the capacitor will find a path to discharge. Since Rd is infinity, it can't able to find the infinite paths. When I supposed to put a R over here, what happens? The capacitor will discharge. Capacitor will be off and discharges. This is for the logic, basic logic. This is for the basic logic. Then how it can be used for holding the input, holding the value of the input. So let me explain, just see. So this is my switch. And this is my capacitor C, my V in, and this is my control voltage V, this is my V out. So when the input is given like this, so during the on state of the Q, when Q is in on state, the capacitor will charge us as long as when I supposed to switch this VC to off. So when I give a negative pulse, what happens? So because of this infinite impedance, the capacitance can't to discharge via this value. So it will hold. It will hold the value. This is called as hold time TH. And once after this is applied, once if this is applied, what happens? The same signal starts to charge. And when this signal is applied, this will hold. And up to the peak, it is keep on charging and holding. This holding because the capacitor cannot able to find the discharge path for itself. So once the signal is getting negative, the same repeats: discharge, hold, discharge, hold, discharge, hold. Okay, so this is the, when I put it like this is the square pulse response. I'm sorry, I'll like this. So I just reversed the diagram. Let me draw it neatly here. So this is the charging, holding, charging, holding. So how it is compared with, let you listen please. So charging capacitor during the on state of the switch. When the switch is off, capacitor will never find a discharge path, so it will hold the charge. Then during the on, it will charge, hold, charge, and during the negative half cycle, it will discharge and hold, discharge, hold, discharge. So let me have the comparison of the control voltage. So during the on time, it will charge. During the short off time, ensure that the off time and on time are very short. And this is the off time during the hold. And